Hello everyone, and then welcome to another tutorial video. So in this video we'll be treating what multiple integrals and then what double integrals. So multiple implies that more than one form of what integration, hence we have double integrals. Okay, so in case you are new to this channel, see more of these videos, I would urge you to subscribe to this channel, turn on your post notification by clicking on the bell icon so that you don't miss out on future videos. Like the video, kindly smash the like button, and then in case you have any questions, just let us know in the comment section, then we will be glad to respond to them as soon as possible. Now, so this video is going to be very, very simple, straightforward, okay, and concise, right? So let's say we have what a function, okay, f of x, okay, which is of what a single variable like a equals the integral of f of x dx, and then we have what ab means that the ab means that we have what a higher limit and what a lower limit. Okay, so we have a higher limit of maybe b and then a lower limit of what a. This is what we term as what multiple integrals. Okay, so we have what maybe integrating with respect to y, and then after that you take the integral with respect to what x. Okay, that's what we mean by what multiple integrals. Once you get this concept, you are good to go. Now let's look at what double integrals. Now from our previous explanations, we got to know that we have what normal integration. That's where we have what only the maybe taking the limit from only a to b, okay, just a to b, and then maybe you have a function of what x, y, and then you have what maybe the x. But for double integrals, you are taking the integral two times. Okay, you are integrating two times. So let's say we have what the intervals from what a to b, and then you'll be given the integral from what c to d. Okay, and then the function will be given as what f of x of what y, because you'll be taking the integral of what respect to y, and then what respect to what x. So you know that c is what the rectangular domain. We'll talk about that later in this video, but this is what I want you to know. This is how what multiple integrals look like. Okay, this is what multiple integrals look like. Just keep this in mind. Okay, this is the most important portion of what this tutorial video. This is what multiple integrals look like. So for multiple integrals, you will notice that we have what the first integral from starting from the lower limit a to the higher limit b, and then we have the second integral, okay, starting from c to d, and now we have the function of x and then y, and then from here you could notice that we have what dy dx. It means that you have to first take the integral of what this portion, okay, this portion of what the function. After that you use the already gotten answer to find what the integral of what the entire portion of what this expression. So let's solve some questions so that you get to understand the entire concept. Okay, so let's say we have what maybe an example. Then we have what the integral of what maybe higher limit 1, lower limit higher limit 3, lower limit 1, and then the other integral with what lower limit 2, higher limit 4, and then you are given the function to what maybe 40 minus what 2xy. Okay, and then you are given what dy dx. So this is the main expression. Okay, this is how the main formula looks like, and then this is a sample question. Okay, this is a sample question to help you understand the entire concept. Okay, so let's see how we solve this problem. Okay, so first we take the closest integral, which is what dy. So we have what the integral of what 4 and then 2, and then we have what 40 minus what 2xy. Okay, and then we have what dy. Now let's integrate this expression. So when you integrate this with respect to y, you end up with what 40y, okay, minus what xy squared, and then you introduce your limits. Okay, so we have what 4 and then what 2. Okay, now let's just substitute the limits. Okay, so we have what 40 multiplying 4 minus what x multiplying 4 squared, and then you subtract that from what 40. Okay, 40 multiplying 2, and then we have what minus x, and then we have what 2 exponent what 2. Okay, now let's proceed from here. So from here we have what 40 by what 4, that's what 160. Okay, and then we have what minus what 4 exponent 2, that's 16, and then we have what x minus what 40 times 2, that's what 80. Then we have what 4 what x. Okay, so from here you could just do your simple expansion. Okay, you can just do your simple expansion, but you can use your calculator to solve this. So to make this simpler, okay, and make this video short, let me just solve this straight away. So we have this will give us what 160 80, that's 80, and then we have what minus 16x, and then we have what positive 4, that's what 12 what x. Okay, so now this will be our new what formula. So all we have to do is just use the second integral, okay, or the first integral. So this could be our first and then this could be our second, but the main point is to know what you are dealing with. Okay, so this will be the new equation, okay, or the new function. So we have what, you take the first one, that's from 3 to 1, okay, 3 to 1, and then this will be your new what expression, okay, 80 minus what 12x, and then with what dx, okay, dx, because initially we use what dy, okay, to end up with that what expression. So let's see how we solve this problem. So we have what, first you need to what integrate this expression. Okay, so when you integrate this expression with respect to x, you end up with what 80x, okay, and then you have what minus what 6 x squared, okay, because when you integrate 12x you end up with what minus 12x, you end up with what minus 6x squared. So let's take the limit. So we have what from 3 to 1, and then let's insert our what limit. So we have what 80 multiplying 3 minus what 6 multiplying 3 square minus what 80. Okay, let me write that, didn't come off well. So we have what 80, okay, multiplying what 1 minus what 6 multiplying 1 exponent what 2. Okay, so let's see how we will expand and all that. So we have what 80 by 3 will give us what 240, okay, then we have what minus what this will give us what 6 by 3 exponent 2, that's what, that's 54. Okay, then let's open this bracket. From here we have what 80 by 1, that's what 80, okay, that's 80, and then we have what this will give us what just 6. Okay, so when you compute the whole of this, you end up with what 240. Okay, so let me just, okay, 240 minus what 54 minus what we have what 80 minus what 6, that's what 74. Okay, so with all of this, once you compute the whole of this, you end up with what 2. Okay, so this will be your final answer for this question. Okay, you could notice that this was quite simple and what straight to the point. So let's take the next what problem. The next problem will be a bit the reversal of what you've initially solved. Okay, so let's take the next problem. Okay, so this is the second question. Okay, so we have what the integral of from 4 to 2, and then from 3 to 1. Then we have what 40 minus 2xy dx dy. So you can notice that this similar to what the initial what problem. So let's see how you go by solving this problem. So you could either pause the video, solve it, and then verify the answer after you are done solving this problem. So let's see how you go by that. So as we already did for the initial problem, we have what, you first take the integral from 3 to 1. Then we have what 40 minus what 2xy. Okay, then we use what dx. Okay, dx. Now let's see how we solve this. So we have what 40x, okay, minus what x squared y. Okay, and then you take the integral from, or the limit from 3 to 1. Okay, so let's insert that, and then we have what 43, okay, minus what 3 exponent 2 y minus the either side, okay, using the limit of 1. So 40 multiplied by 1 minus what 1 exponent 2 y. Okay, so you could just solve this. When you solve this, you end up with what 40 by 3, that's 120. And then we have what 3 exponent 2, that's 9y minus what 40 by 1, that's 40. Okay, minus what this will be what just y. Okay, this will be just y. Now You could just simplify this further to get what this will give us what 120 minus 40, that's what 80 minus 9y plus y. So this will give us what 8y. Okay, so from here you could just take the second what integral, that's from 4 to 2. Okay, so we have what from 4 to 2, and then we have what 80 minus what 8y. I'm trying to prove something. Okay, we are trying to prove whether you take the reverse will give us what similar answer or not. That's what we are trying to prove. That's why you are going through the entire process of solving it in the reverse direction. Okay, so we have what, let's see how we solve this. So we are from 4 to 2. Okay, the limit from 4 to 2, and then used what we already had for the first what integral. Okay, so we have what, let's integrate this. We have what 80y with respect to y. Okay, so we have 80y minus what we have 8y squared on 2. So you could just solve this straight ahead, and then you get what, let's say 80y minus what 4y squared. Okay, you could just do that straight ahead, and then let's have what our limit from 4 to 2. Okay, and then let's see, we have what 80 multiplied by 4 minus what 4, then we have what 4 squared minus what, let's put this in brackets. So we have what 80 multiplying 2 minus what 4 multiplying 2 squared. Okay, note we are trying to prove whether the reverse will give us the same answer. So initially we had what 112. Okay, and let's check whether this will give us the same answer. So 80 by 4 minus 4 and 4 squared. Okay, so when you compute the whole of this, okay, when you use a calculator to compute the whole of this, you end up at what 112. Okay, so this means that whether you use what the reverse, okay, or you use what straightforward, so either you use what this expression, okay, 4 2, you just have to take note of how you write what the entire what expression, okay, dy dx, or you use what 4 2, okay, and then the integral of what 3 to what 1, then you have what 40 minus what 2xy, and then we have what dx dy. Okay, x dy, provided you write it in their right order, okay, you end up with the same answer. Okay, provided you write it in the right order. Okay, so you can notice that the limit from 4 to 2 goes with dy. Okay, and then the integral with limit 3 to 1 goes with what dx. Same applies over here. So limit from the integral with limit from 3 to 1 goes with what x. Okay, and then from 4 to 2 goes with what y. Okay, right. So in our next video we'll be treating what Fabuni's theory. Okay, Fabuni's theory. So I'll see you in the next video. In case you have any questions, just let me know in the comment section. Subscribe to the channel so that you don't miss out on future videos, and I will see you in the next video.